Writing a C++ program creates a set of precise instructions that actively command a computer's underlying memory architecture. To take control of that hardware, we will master three essential systems: building the boilerplate setup, executing commands through the terminal, and allocating memory via variables. Before writing a single line, you must establish a strict prerequisite environment. You need a dedicated code editor, like VS Code, to write your script, and a C++ compiler installed on your machine to translate it. Securing this environment and mastering these initial steps allows the machine to interpret and execute the specific logic we are about to write. Every C++ file requires a mandatory starting architecture, known as boilerplate code. You will write this skeleton into every single script you create, regardless of what the program actually does. At the very top of the file, we write include IOStream. This specific input-output stream header gives our isolated program the ability to communicate with the outside world. Next, we write int main, followed by a set of curly braces. This main integer function is the absolute starting line. Whenever you run your program, the computer will always begin executing its logic right here, inside these braces. To push text outward to the user's screen, we use the command cout, short for character output. We follow this with two less than symbols and place our text inside double quotes. C++ is a strictly case-sensitive language. If you type cout with a capital C, the system will not recognize the command and will return an error. You must mirror the exact capitalization required by the syntax. Every complete instruction inside your main function must end with a semicolon. It acts exactly like a period in an English sentence, a mandatory statement terminator that tells the system your thought is complete. You can chain multiple text outputs together on a single line by adding more less than symbols. If you want the text to break to the next line, you must force it using the endl command or the \n character at the end of your string. Only by mastering these rigid syntax rules can you transform arbitrary text into executable logic. Human-readable code is entirely useless to a computer's processor. Before the hardware can act, your text must be instantly translated into pure binary. The compiler acts as the essential translation engine, bridging the gap between your written script and the physical hardware that only understands electrical signals. Step 1. Command the compiler to transform your text into a distinct executable file by typing G++, followed by your file name. Step 2. Run that generated executable file, pushing output to the screen. The exact command depends on your machine. Mac users execute the file by typing /a.out, while Windows users run their executable file by typing a.exe. Writing the script and running the script are two entirely distinct computational phases, permanently separated by the compiler. In traditional math, a variable is an unknown placeholder. In programming, a variable serves a very different purpose. Declaring a variable allocates a labeled container in physical memory. When we write age equals 25, we route 25 into that precise space. You must follow strict conventions. Labels must start with a letter or underscore, or the compiler will violently reject it. Before the container can accept data, you must declare its data type. This provides the required blueprint that dictates exactly how much memory space the container needs to occupy. We use the data type int, short for integer, to carve out space for whole numbers. If we only need to store a single letter, like a grade, we use the char data type, which requires much less memory. When assigning a value to a char variable, there is a strict syntactic requirement. Isolated characters must be wrapped in single quotes, not double quotes. Declaring variables is the physical act of claiming and structuring hardware space for your program's specific needs. Whole numbers don't cover every scenario. To store precise decimal values, like a price tag, we bypass integers entirely and declare either a float or a double data type. When assigning a value to a float, you have a unique mandatory requirement. You must append the letter F directly to the end of the number. This prevents the compiler from confusing it with the larger double data type. To display the data you've stored, you feed the variable's precise name into your output command. Crucially, you do this without quotation marks. If you add quotes, the computer will literally print the variable's name, rather than the data hidden inside it. Variables allow data to shift and update during execution, transforming a static script of text into a responsive, evolving program. You have now successfully executed a complete programming lifecycle. You established the boilerplate architecture, structured physical memory with data types, formatted your terminal output, and used a compiler to translate your logic into pure binary. Looking at this split-screen comparison, the direct relationship is clear. Syntax-perfect code on the left directly controls the accurate terminal output on the right. Your task now is to build a formatted profile card entirely from scratch. You will need to declare distinct variables for a name, age, and grade, and output them to the terminal using proper line breaks. These foundational mechanics, compilation, memory allocation, and input-output, remain the standard tools used to engineer global software networks and complex operating systems.